Okay. So OpenRewrite, it's a framework for doing large-scale automated refactoring. And on the surface, you might be wondering, well, how is this going to be different from like the refactoring you might see in your IDE? Obviously IDE refactoring has become more and more sophisticated over the years. But and of course, OpenRewrite will do many of the things that your IDE will do, because your IDE's refactoring is typically kind of focused on the task at hand. So you'll be in a file that you're touching, you'll see some yellow warnings, you'll get some some hints that you can refactor this, and you might do that. But what about all the files you're not looking at? Like what are other things are hidden in those things? So OpenRewrite kind of takes a different approach, and it kind of like looks holistically across your entire project or across your entire organization's repos to find these common refactoring patterns. Additionally, Rewrite kind of goes a bit further in that instead of just doing these simple, one-step refactoring operations, they're composable. So if you compose a bunch of refactoring operations together, then you can start doing these higher level things like migrating frameworks. So think something like migrating from JUnit 4 to JUnit 5, Java 8 to Java 11, or even just taking an assert library like something like JUnit asserts and moving to AssertJ. So Rewrite's kind of bread and butter is doing that sort of refactoring operation and doing a scale across your organization. So it's pretty exciting. Okay. So call to action. For code, maintainability is destiny. I think all of us here, and this will probably hit home for most of us, we probably spend 20 or 30% of our time, probably even a little bit more, doing tedious code maintenance, and we do it manually. I like to like use an analogy. It's kind of like pulling weeds. So I have a story, so bear with me. I will bring this right back to what we're talking about in a second. When I was like 10, 11 years old, my dad used to make me go pull weeds every spring. I mean, we lived in 20 acres, like in rural California. So you can imagine we had a flower bed all around this lawn. It's not like a small lawn. It's like, I've got 20 acres. I'm going to make a big ass lawn. So there was a flower bed all around it, and I would spend weeks pulling weeds every spring. And I used to just think, this is stupid. There's got to be a better way of doing this. And so we played this song and dance for about 3 or 4 years. And finally, like when I started becoming I get 15, 16, one spring I'm dreading, the pulling the weeds. And my dad brings out this rototiller and he rips up the entire flower bed in about an hour and a half. And I'm going, well, what the heck? And it turns out he's like, yeah, I was just trying to keep you busy. So I kind of relate that story back to this maintenance, right? Like, like migrating something to, JUnit 5, there's a lot of tedious, work. As a matter of fact, at a previous job, I actually had to do that migration from, I was using JUnit 4, we had to move to JUnit 5, and I spent about 3.5 weeks of my life just manually kind of bringing these forward and then certifying that they still worked. And it wasn't, this is a medium-sized company, so we're talking probably 30 or 40 repositories, but you can imagine these larger organizations, you can spend months doing these type of refactorings. So another kind of interesting point with, something I think we probably all come up against is if we're in like an agile or a Scrum type environment, typically your work is always tied to some sort of business value. And it's these type of tasks that tend to kind of fall to the wayside. And, basically you kind of have to fight to pull weeds, and it's terrible. Why should we have to do that? So this is kind of a pain point that OpenRewrite is trying to address. Like, what if we could do a lot of this in an automated fashion so we can get back to doing what we want? And again, doing this maintenance is kind of like an enablement technology. It enables your developers to do the real work, right? To provide business value, to provide features that are meaningful to the business. So I just want to point out, though, that, where the obvious choice might be, well, I'm going to take these legacy systems and I'm going to bring them forward. You might, bringing your legacy code base up to date is just, it's great. However, OpenRewrite and this mass refactoring is not just about legacy frameworks. Sure, framework upgrades are great, but it also can be used for doing security remediation. So think something like this. Say a CV comes out and basically, you've got some things in your organization that are using the library that maybe the CV is for. How do you quickly find all the places where you're using that? And then further, how do you go about actually remediating that in a timely fashion, especially if it's critical? There are plenty of tools out there that will, scan your repo and go, hey, you've got this dependency that has a security leak, but they kind of leave it to you. The onus is on you to fix it. So with an automated refactoring tool like Rewrite, you can actually go a step further and actually do the remediation and get a pull request out there on all the repos that might have that vulnerability. So that's pretty cool. Additionally, you might want to enforce best practices. So invariably, your developers are going to check in code that maybe doesn't follow best practices. Maybe the modifiers are not in the correct order, or maybe you've got some sort of formatting standards that you want to kind of enforce. Rewrite can also be used to also do that. And then finally, Rewrite's good at doing developer enablement. So as an example, we have one company that is actually trying to replace feature flags that are no longer necessary. So they can use Rewrite to kind of find their feature flags, check to see if that feature flag is still in use. And if it's not, they can actually pull that out of the code and do that in an automated way. In that way, Rewrite can be kind of customized to these kind of internal tasks that would normally have to just be done manually. So it's pretty great. So I'm going to kind of relate my story, how I got interested in OpenRewrite, and we'll see if it resonates with everybody else. So how long would it take you, or did it take you, for your organization to move to something like JUnit 5? So going from JUnit 4 to JUnit 5. And this is a good example of what makes this a little bit difficult. Normally as a developer, you're going to pick, tools that do regular expressions and do these kind of, these text-based searches. You can do a pretty good job. But then you run into something like this. You'll see in this code, we're using the JUnit rule, which is a JUnit 4, class. And it's also using, the throw inside this method. So to fix this and move to JUnit 5, you need to do this. You'll see that the imports were removed, and we've added some new imports. So we've changed the test annotation to the Jupyter API. We've added a static import for the assert throws, and this is the interesting piece. You'll notice now that we're using assert throws, and we're actually pathing what was previously in the method into this lambda expression. I would have thought this wasn't possible with automated tools before I had kind of run across Rewrite. And this is part of the reason it takes so much time is you would have to, as a developer, go through and find each one of these cases. And if you've got hundreds of these, then you can imagine. So again, going from something like that, where, again, this, method body is getting thrown into a lambda expression is honestly pretty magical. So this is kind of how I got hooked with this framework. So let's talk a little bit about how it really works. Rewrite is basically taking source code and converting it into an abstract syntax tree. I'm sure you probably, from your college days, you probably remember the term abstract syntax trees. It's basically taking text and then parsing it into tokens and then attributing type information to it and whatnot. So that's kind of what Rewrite is doing, but it kind of takes it a step further. Obviously, the Java-C compiler could care less about comments or white space. It just cares about the tokens. But Rewrite actually preserves all of the formatting. So that's one, I guess, unique attribute. Say again? Okay. That's one unique attribute with our ASTs. The second thing is, it may not be obvious, like the structure of this looks like Java, but knowing what the actual type is, like knowing that, what is the type of X or what is the type of C, that information is actually also embedded in with these ASTs. So that's also kind of a unique attribute of this AST. And then finally, Java C, when it basically parses things, it has its own AST representation, and it actually has cycles. So one of the other things that rewrite has to do, because we actually take these ASTs and serialize them out onto disk and whatnot, is we actually have to break those cycles. So these things collectively kind of make things work. I'm going to, like I said, this is pretty light on slides. I'm going to be doing, showing a video that kind of demonstrates some of the capabilities, and then we'll be following that up with a coding exercise. I can take a break between the video and the coding exercise, so people can maybe come up for air and ask questions. I tend to talk pretty fast, so I apologize if you're watching this video at some point and trying to you double speed. It's probably going to be very squeaky, but oh well. Okay, so I'm going to move over to our demo here. All I'm going to do is just run this video, and I'll pause it at different points and kind of point some things out. So this is an example of Rewrite doing Spring Boot 1 to 2 migration. So in this particular case, let me pause a second. The UI you're looking at here is something that we've been working on, but just know that every recipe that you're going to see here is available in the open source framework and can also be run via Maven or Gradle build files. So one thing to be very clear is all the recipes will be open source, are always open source. They're going to be Apache licensed. We don't want to get into a situation where some recipes are proprietary. We didn't really want to do that. So everything is in open source. We're using this because it just happens to be a really nice way of visualizing some of these changes. So what we're going to do here is, this is going to take a recipe and migrate the Spring Pet Clinic from 1.5 to 2.0. So you can see it actually runs really fast. And to give you an idea of kind of some of the things it's doing. I didn't mention this, I should have. In addition to having an AST for Java, we also have ASTs for XML, and then built on top of that, there's an AST for Maven. So that actually allows us to do some very sophisticated things with Maven properties, dependency management, that sort of thing. We have ASTs for YAML files, and we have AST for property files. We also have on our roadmap long-term, we're going to start thinking about other languages that would be useful for this. But right now, our focus is primarily on Java right now, which is why we're at the Java users group. So you'll see here, it already basically migrated the version from 1.5 to 2.4.5. It's got to do things like, we know that we're not supposed to be using, the Hibernate validator. We should be using JavaX validation. So it's basically going through and making these changes. Time length is no longer there, so it just gets rid of it. And also kind of a subtle thing is, notice it's actually getting rid of the property file, and also it'll get rid of any dependencies. So it's, like I said, it's pretty sophisticated because we have an AST kind of built on top of Maven. Okay, let's keep going. And another thing is because it's going to the new version of 2.4, we're going from JUnit to JUnit 4 to 5. So this actually, I mentioned that the recipes are composable. So this recipe for bringing us from Spring Boot 1.5 to 2.4 is also going to be converting this to JUnit 4 to JUnit 5. So it's doing all of that in line. So a couple of things to kind of note here, you'll see that it's taking your generic request mappings and using the more specific Git mappings. Again, if you're a Spring user, you'll recognize this right away. It also does things like this, like the path variable. You don't really need to have it here anymore. It's no longer required if the parameter name matches. So it's going through and kind of doing all this stuff for you. Okay. So again, these type of migrations, and I've done them, can take weeks, especially if you're going to do it across your entire stack. And this is kind of scratching the surface. I think that as our community grows, we'll start seeing more and more sophistication kind of built into these things. So the next one is kind of an example of how you might go about converting JUnit asserts to AssertJ. This is another migration I actually did at a previous company I worked at. Again, a couple weeks of my life to do this. Another point, I wanted to point out that this time we're actually using the Maven plugin to run the recipe. So I just kind of point out that all these recipes run, in Maven and Gradle, and then, again, we have the UI. Okay. So we'll let it do its thing. Pretty quiet out there. So again, this is kind of interesting too. Let me hit a pause here because the structure of these methods is a little bit different, right? AssertJ is a more fluent style, whereas JUnit is not. So you can see here it's taking something like assert true and converting this to an is true method. So this is it's kind of pointing out that because OpenRewrite is semantically aware, it can kind of do these very sophisticated operations. Okay. Sorry, like I said, I talk fast, so a little dead air here. Of course, after you convert it, you want to make sure it runs. So we're going to do that standard smoke test. Fire up the application now, see if it actually runs. So you'll see the banner pop up here in a second. There it is. You can see it's 245. So it starts just fine, and open up the browser. Pet clinic. So that's pretty compelling. That's done without any user intervention or any developer intervention at all. That's all automated. So this is a second class of issues that is kind of near and dear to my heart. SonarQube. So I don't know how many people have SonarQube running in their build environment. We had Sonar, and it was a constant battle. Like you'd run across a couple of issues. You might have 6,000 or 7,000 of them in your code base, and SonarQube will give you this very anonymous, it's going to take you 800 developer days to fix all these issues. So it was always kind of a battle with setting a threshold of how many SonarQube issues you want to have before your build breaks. And honestly, there wasn't an easy way to kind of reduce that. We would try to set a limit of SonarQube issues, severe and blockers, and then we would try to dial it down. It just didn't work well. It kind of fell to the wayside, and when you encounter business pressures or you have to get a build out that day. So this is kind of interesting too. So what if you could remediate a lot of those things instead of 800 developer days? What if we could have OpenRewrite do that for us? So in this case, we're just going to show a couple of examples of how this might look. These are simple ones, but like I said, rewrite can do quite a bit more sophisticated things. So in this case, we're just basically going to shift the order of the modifiers, based on how Java language standard says you should lay them out. You'll also notice we're actually running this across a bunch of open source projects. It gives you an idea of how fast you can kind of do these operations across an organization. And so we'll look at an example of what this looks like. I don't think the results are going to be that surprising to anybody that's done this sort of thing before. Okay. So yeah, so all it's doing is just shifting these things to the proper order based on the Java language spec, which is something that would have to be done manually otherwise. I guess you could try to write a regular expression, it'd be kind of tricky. And then how about method names with matching a certain convention. In this particular case, we wanted to use camel case, so that's what this is going to do. Again, these aren't really that different from what you might see in your IDE, but you can do this across a project or across your organization in one shot, which is pretty darn handy. A couple of things that, to note, again, if I pause here, you can see it's just taking underscores out and then making these properly camel cased. Sure, you can change the method declarations, but you also have to change any method invocations. So that's kind of what this is saying here, is you also have to make those changes when they're invoked. Finally, what if you can detect when an exception is not necessary to be thrown out of a chunk of code, and you can get rid of those. So these are all things that are kind of like in that cleanup vein, where you could run these on a fairly scheduled basis across your org to basically make sure you kind of basically enforce these things. So pretty cool. And of course, you could imagine you could do this with formatting too, if you wanted to enforce some sort of source code formatting. Okay, so yeah, it's just dropping the throws. Now we're going to start getting into things that are kind of like on that borderline of Java 8 to Java 11 or Java 17. So this particular example, this is removing calls to the primitive constructors. I don't know if people if they've made that migration to from Java 8 to Java 11, you will have noticed that these are deprecated. You're not supposed to use a constructor. You should be using the value of version. Like there's a static method on these. The static method is the preferred approach because they do some caching of normally used values, so like integer. There's benefits to it. Starting in I think Java 16 or 17, these are not going to be warnings any longer. They're actually not going to work. So that cleanup exercise there is going to be necessary if you're going to move, to Java 17, later on. Moving to security. This is doing, basically checking for an XXE vulnerability, which is basically your XML parser can download external entities or external DTDs. You really don't want it to do that. So this thing here is going to find places where you're using the XML parser, and it's just going to make sure that a couple of properties are defined. It's certainly something that's easy to miss as a developer. So this is a pretty straightforward thing. So this is that, again, this is kind of touching on that security remediation, not only scanning and find it, but also adding a fix for it, like immediately. So you can see all it's doing is just finding a reference to this XML input factory and then adding these two properties. So nothing too surprising and nothing terribly hard, but it is hard if you've got a gigantic organization and you've got hundreds of repos. How would you find all cases where you're using that? This is kind of a fun one too. This is a search visitor, which will scan through repos looking for places where you are using secrets inside your code. So generally, it's kind of horrifying that you might have that. Luckily, and again, I'm not to pick on Spring Cloud Config Server. These are all in tests, so it kind of makes sense. These are like fake RSA keys, but anyway, this is something that you could use to kind of find this and get those out of your code base. Okay. Moving over now, we're going to get out of Java a little bit and go into a little bit about some of the capabilities that we can do with Maven. So in this case, we're just going to do a search. We're going to look for JUnit in the compile scope. So this is basically, you shouldn't have JUnit anywhere in your compile scope. That would tell you that something is leaking that dependency transitively or maybe explicitly into your compile class path, but you don't want. So that's what this recipe is doing. It's just looking for places where this is referenced. Now, keep in mind, it actually will find where it's transitively included here and go, hey, you've got a problem here. So we can take this a step further. We can almost do the same thing. Now, this is actually a refactoring visitor that's going to find the same JUnit, in the compile scope and actually add an exclusion anywhere it finds it in compile scope. So again, a lot of this is possible because we have a semantically aware AST that is aware of like how Maven works. So you can see here, it found that same, transitive dependency and it added exclusion for us. So that's pretty handy. And, a little bit harder to track down if you're a developer trying to find these things. It can be done, but it's a little bit more difficult. Another thing that's kind of fun is what if you want to upgrade a dependency? And this, again, this could be, driven by, a security vulnerability. You want to find out where it's used. One thing that's really kind of interesting here is you'll notice here that we're actually using like basically a node style, symver selector here. So you can basically say, I want to upgrade this library to the latest 5.x version. That's kind of what this is going to do here. Same thing. So what this is going to do is find all places where this is used and then go make that change. So I want to stop here too. There are a lot of times where you'll find the dependency is either in a dependency management section or maybe it's defined in a property. You can see because we have the semantically aware AST, we can actually track this all the way back to the property where we actually set this. So rather than having to like maybe make this modification anywhere we see the dependency or in the dependency management section, we can kind of trace it to its root and change it in one spot. So it kind of gives you an idea of some of the capabilities. Okay, I've talked a lot, haven't given anybody time to talk at all. So I'm going to take a small break here and see if there are any questions so far.
I can ask some questions.
Okay.
So the application that you put on your screen, it has the name of your employer on that. UI around it, or it's an instance of OpenRewrite that you just go on? Is the thing, or is something around?
I am having a tough time. Did anybody else hear what he said? Because I'm getting, he's kind of breaking up.
I couldn't understand it.
I couldn't hear him.
Okay, I think he said something about my employer is on, is on, obviously the branding for the app is there. The answer is yeah. Again, I just want to point out, we just wanted to use that to kind of visualize what is happening. I'm not, what we're really trying to get across is kind of the power of what this automated refactoring framework can do for you. We want to, and again, later on, I'll provide some links on how you can use some of these tools within your Maven and Gradle-based builds. So I think that's what he asked.
Yeah, sorry, can you hear me now?
I can, yes.
Okay, I went on a walk and that was probably the worst part of the walk. Yeah, I was asking if that was an actual OpenRewrite interface or whether that was something you built for your employer on top of OpenRewrite.
That is built on top of OpenRewrite, correct. So where OpenRewrite is going, like I said, the recipes are always going to be available open source. You are always capable of running those recipes, via adding it to a Maven or a Gradle build. You can imagine that can get a bit tedious if you've got hundreds and hundreds of builds within your organization, but you could certainly do it. The SaaS solution that you're looking at there, that is something that we're, again, we have to at some point, we like to eat and like to pay our bills. So that's kind of how we are going to kind of fund some of this. Any other questions?
I have more questions. I'm still nervous about my connection though.
Okay, go ahead.
So is the entry point, I saw you do this across a whole code base. Can you talk a little bit about how that works versus like doing it in a single code base? Because we're all very used to doing tricks using Maven on a single repo, but how does this work across repos?
Yeah, I can definitely answer that. So what's actually happening is at build time on all of downstream repos, we are basically taking the ASTs or generating the ASTs from source code. So think about like just one extra step in the build process is to take those ASTs and basically spit them out as artifacts. So literally we're writing out the AST and we're just writing it out to a file, and then that is basically then being stored in the SaaS, and then the SaaS is operating off of these things. So there's a service that's ingesting all of these, and then basically once those are ingested, there's a separate service that then is running recipes across all those ASTs concurrently. And of course, you get all the bells and whistles of being able to select which repos you want to run recipes on. That sort of thing. So we're just scratching the surface of those capabilities. But again, I want to make sure I stay on target with the open source and what's available today.
So when there is like diffs that you show, can you apply those right away, or would you have to lift those up and bring them to Git or something?
You can actually. That's the plan, is to kind of integrate this where it'll actually create pull requests. Actually, I'm not sure if Greg is on. I think it was Greg who was working on one. One of my coworkers was working on that feature today. Is basically trying to get the groundwork for that, where you'll be able to go in there and basically generate pull requests against all of the repos. Or are you going to create a fork, or is this going to be like something that's directly against if it's a forked repo, that sort of thing. So there's a lot of details to work out there, but that's kind of where we're going with it.
It is certainly very cool.
It's somewhat magical. I mean, honestly, the first time I saw it, I was like, that it can't be right. But it's pretty cool. And actually, the coding exercise I'm going to do next will kind of give you a small taste of how easy it is to kind of implement these sort of features, and then we'll kind of wrap it up. And like I said, I don't expect this to take the 2 full hours because I talk really damn fast. But I guess we can move into the coding exercise unless there are other questions.
I got one question.
Sure.
You said, so Tyler, you said this is mostly, or this is Java based, and then I'm also working with like properties files and Gradle and that kind of thing. Are there plans to move to other languages, both JVM and possibly otherwise?
The answer is yes. So today we're obviously focused on Java and the things kind of supporting that. We have been talking internally about doing something for TypeScript. That seems like there seems to be a lot of interest in TypeScript and JavaScript. Obviously, dynamic languages are a different challenge. However, if a dynamic language has something that can statically compile them, like again, TypeScript is kind of like our gateway to doing that, then we should be able to support the same type of capabilities in TypeScript. But we that's just in preliminary discussions. We haven't done anything with that yet. We actually just hired somebody that will probably start looking at that. The other one that we're keenly aware of is, you'll notice that all of our dependency management was in Maven. We know that we need to support that in Gradle as well. But of course, in order to do that, we need to have an AST built on top of either Groovy or Kotlin. So, that sort of thing, yes, we definitely have that on our roadmap. We're painfully aware that we need them, but, this, first cut is Java, and this is going to be what we take forward initially, and then kind of expand from there.
Cool. Thanks. Looks great.
Cool. Any other questions? Okay. All right, we're going to switch gears here a little bit then. Okay, so I promised we're going to do a recipe. So what I ended up doing is I just went to AssertJ and I found a capability that we don't yet have. In this particular case, I wanted to target, you can see in 3.12 that they added this new recursive comparison API, and they've deprecated this other thing called is. It's like I picked the longest method name for this demonstration, so bear with me. So what I want to do is I want to demonstrate how we would build a recipe that'll replace this with this new recursive API. So let's go to IntelliJ. Now, I've tried this before, like just writing this out, and there's a lot of dead space. So I'm going to be doing some copy and pasting, so I don't really type that fast. But I want to kind of walk through this and like how this would go, like how a developer might go about this. So this is just an example of what this would look like before and after. So what we're really trying to do here is this thing is just recursively using reflection to check to see if these objects are equal. So obviously these look equal, and if I run this test, I'd expect that to work. Maybe. Hey, it passes. Okay, cool. And then obviously if I change one of these so it's a different address. All right, it fails. That's not really that surprising. So it's failing here. The new recursive API is basically kind of just using this use recursive comparison, and then it is equal. So these are functionally equivalent. So like if I comment this out, I would still expect this to fail. Yay, and then let's put it back. All right, this is probably pretty obvious, but just kind of, prove these are functionally equivalent. Cool, okay. So what we want to do is we want to build a recipe that is going to essentially replace this method invocation. I know it's a method invocation in our AST because I've been working with this a while. After this, I'm done this coding exercise, I will have some links on where you can find more information about this. We're always around to help. We have a Slack channel. You can always get a hold of us, through that, or open an issue on one of our OpenRewrite projects. So, okay. So what I'm going to do now is I'm going to go up here and we're going to basically create a recipe. So a recipe is kind of the unit of work that's basically I'm going to do something. Recipes are composable, so you can have one recipe that embeds 8 more recipes that do some higher level function, but we're obviously doing kind of this very simple thing. So we're going to extend recipe. And it's complaining about not having all of the methods implemented, so we'll do that real quick. One thing you'll notice you probably noticed in the UI, all of these things have metadata, like they have a name, they have a description, whatnot. All of that metadata is actually coming from the recipe. So like if you were to look at some of the other methods in here, you can see there's like get description, so tags, languages, that sort of thing. So a lot of the metadata that we use to generate it on the UI is there, but that also is available in the build tools. So like you can say Maven describe, and you can actually kind of discover what recipes are available. There's also some generated documentation off of our docs page that shows you a complete reference of all the recipes we have so far, and it's obviously going to be getting bigger as our community grows. I will show that off after I'm done here. Okay. So again, I'm gonna do some copy and pasting here just to speed this process up so you don't have to just sit here watching me type. As I mentioned, 2 returns. I know it's a method invocation. I also know that a recipe is always paired with a visitor. So I'm going to do another override. I'm not going to go into too much detail about how the API works. We can leave that to another discussion, maybe another talk. So what we're going to do here is we're actually going to create this visitor that's actually going to do the work on behalf of this recipe. So let's see. I'm going to create an anonymous class. Okay, and then I know inside here, I'm going to override visit method invocation. So again, I'm going after that method invocation. Originally, we're going to convert it to another method invocation. So the first thing that we probably need to do is you'll notice that this is actually calling super. That's an important thing to do because that's how rewrite navigates its AST. So, if you're on a method invocation and it has arguments, you need to make sure it navigates into those arguments. You need to make sure that it navigates into all the subtrees. So that's why we're calling super here. So this is basically right now not doing anything. It's not transforming this method invocation at all. It's pretty much whatever you get, you get back out. So what we're going to do now is we need to have some way of basically saying, is this the method we're looking for? And if so, then we want to transform it. So what we're going to do is we're going to introduce a utility method that is in rewrite called a method matcher. And the method matcher just takes a string signature. This signature might look really familiar to those that have used AssertJ. It's kind of following, roughly the point cut expressions in AssertJ. So all this is doing is just, what object does this method exist on, and what is the actual method name? This dot dot here is kind of like a wild card, basically saying any arguments. It's relatively straightforward. What's nice about this now is I can now use this method matcher to basically quickly determine if this method is indeed the one I'm looking for. So that's what I'm going to do next. Okay. I'll get to this template stuff in a second. So what this is doing now is basically saying, hey, if this method invocation matches this signature, then I want to transform this in some way. The next piece of this is, how do I transform this thing into this thing? And so you'll see here, this is actually, if you're thinking in terms of what I've just said about how rewrite is converting this to an AST, if you could generate this AST, you could certainly do this without any of the things. But however, building these ASTs is really complicated for the most part. So there's another facility that I think is kind of a game changer for rewrite. This thing has been rewritten so many times, as we kind of tweak with the API. So going back, we're going to use a template. And this allows you to express the code as a string. This isn't actually that surprising. So you'll see here, it's that use recursive. The one thing that's kind of interesting here is you'll see that actually we need to add a parameter here. So like what has to happen is we need to be able to pass in the argument that's here. Here, let me get this in common. So what we're really trying to do is we're trying to take this, whatever is here, and pass it in here. One thing you need to be careful about here is, like, this would be hard with the regular expression, is that this necessarily isn't a variable. This could be a method call. This could be constructing a new instance of the object. So this is totally something you could see in code. So maybe that's perfectly valid as well. So it's kind of interesting about that. That's why it's interesting to use parameterization. You can actually take what was there and then take the existing AST and kind of splice them together to create these new ASTs. So this template is basically the syntax we need. You can see what we're doing here is we're getting that. So one thing I need to describe here is all of the elements being passed to visitors and returned from visitors. They're immutable. So if you want to make a modification, you have to use a wither method. So basically you're creating a copy with changes. So what's happening here is we're basically saying we want to modify the existing method invocation using this template, using this code. We use a coordinate system. So you can see here, we're actually using the original method coordinates. We're saying we're basically going to replace this inside the AST. And you'll see we're also taking the arguments from, honestly, I could have just as easily done this. We're taking the original argument, we're making sure we pass it in the template, which is then going to be inserted here. And then finally, this is a little bit confusing, and I'm not going to get into too much detail here. I know that, again, just from working with this is a method invocation, and this method invocation actually has a selector. That's another method invocation, and this method invocation has a selector that ends up being this. So one thing you'll notice is that if we replace all of this with this there, we need to make sure that we grab the original selector from the original statement and make sure we tack it on. So I'm not going to touch on this too much. This, it can be a little bit mind-bending if you were to read this. Just trust me, that's how it works. And there's lots of help in our Slack channel and tutorials and whatnot that kind of describe that in a little bit more detail. So that's really it. That is all you need to do to basically make this change. So the next thing is, how do you go about testing this and making sure it actually works? So that I'm going to switch gears now. I'm going to go over to a testing harness that we have built. So it's called Java Recipe Test. One thing you will notice is this is actually written in Kotlin. And the primary reason we use Kotlin is because you get multi-line strings here, and multi-line strings are just, it's just a lot more handy. We do know that, you know, Java 15, I think, came out with multi-line strings. So at some point, you'll probably see a Java variant of this test harness. But for now, it's Kotlin. So if you're using IntelliJ, it's pretty straightforward, you know, to use this. So let's write a test harness real quick. The first thing we need to do is the test harness gives you the ability to basically tell it which recipe is under test. So that's what we're going to do here. Maybe. Okay, so we're basically just instantiating our recipe. The way this works, the way this assert works is you basically provide it some source code of what the original thing looks like. Maybe. And then again, you do the same thing afterwards. Help if I think IntelliJ is trying to be too handy. So what I'm going to do now is I'm just going to just quickly fill these in. I'm going to cheat and cut and paste. Okay. So this looks familiar, right? This is similar to the sample we were looking at, except I've added a couple of fun little hooks at it. So first time, you know, basically that's the one that's kind of what the original was. I've also created just the assert, the abstract object assert, and you can see now I'm calling my assert. We should be replacing that, right? The other thing I did is I actually passed this in as a constructor, you know, a newly constructed object, so it should correctly migrate that. And then finally, just to be more fun, I created a method that also takes the actual object and returns the assert object, just to kind of demonstrate that you would have a real tough time doing this with regular expressions and catching these cases. So this is something that I think OpenRewrite really excels at, is it can find this because it knows semantically when I get to this thing is actually that method invocation. So I'm going to now do the after. And hopefully the demo gods are with us. So all this is doing is basically saying, given this code running this recipe, I expect the code to look like this. So you can see here, I'm basically expecting it to use, you know, they're using recursive comparison and whatnot. So I run this. Let's see if I did this first time. I haven't been able to do it yet, but maybe. Oh, I got a green. So it worked. And I can prove that it works by just adding some white space in here to make it not work. So we'll add an extra line in here. You get an idea of what the test harness looks like when it doesn't work. So you basically get in here, you can basically do a diff. And you can see it's just catching the white space. But what it did do is it actually took all of those things and converted them to the way we would expect. You can imagine how many hours this will save you if you're doing this across a large code base or whether you're doing it across your organization. It's these type of things that are really powerful. So you can imagine if you were an organization that has your own internal libraries and you want to make a breaking change, it's a little safer to do that because you could write a recipe that will migrate all your downstream projects to convert the breaking change or to use the, you know, something different. So I think this is kind of a, you know, honestly, and again, maybe I'm biased. I feel like it's kind of a game changer with you know, the way I think that we're going to develop software in the near term. So pretty excited, which is probably why I talk so fast. I don't know. I'm going to go back to my slide deck a little bit, maybe. Okay. I want to talk a little bit about capabilities we have today. I kind of mentioned, you know, we have some building blocks already. So, you know, like things like find type, change type, auto format. That's another thing that I kind of glossed over, but is actually really tricky. You'll notice that we're inserting code and it looks stylistically similar to the code around it. That's because the auto formatting that's going on behind the scenes is trying to maintain formatting. So that's actually really hard. And I'm sure we'll be working more on kind of refining that. So, think of, if you go to like IntelliJ and you open up the format, the formatting tab, you think of all the different tabs and all the checkboxes. We basically are trying to reproduce that and do that at scale. So we have some best practices already, for Spring JUnit security cleanup. I kind of demonstrated some of those in our SaaS framework migrations. We kind of demonstrated Maven dependency management and search. Like I said, there's definitely room for doing custom recipes. Like I mentioned removing feature flags that are no longer used, migrating internal APIs or fixing CVEs. Finally, I didn't touch on this much. I mentioned that we have an AST for YAML. We actually have built and extended that a bit to do some infrastructure as code recipes as well. I haven't done a lot of work like myself in that area. That's something that I think mostly Jonathan's been working on. But we can certainly talk about that too if people are interested in that sort of thing as well. And finally, before I go anywhere, I wanted to, I kind of promised this. I mentioned, so what we're doing now is we're on docs.openrewrite.org, and I'll make sure I get links out to probably to Sean. Are you best to send links to attach to the meetup?
Hey, Tyler, this is Spencer. I can actually run with it.
Perfect. Okay, perfect. I'll send links to this as well, but I want to point out, inside the reference section here, you will find all of the recipes that are currently available. This is an ever-growing list. We're growing it pretty quick. So you'll see here, even in Java alone, you'll see there's a bunch of subcategories for Spring, boot. So these will be expanding. Obviously, we had a lot of Spring experience on our team, so some of this comes from just I guess low-hanging fruit with respect to Spring. But know that there's also a bunch of things for the other thing that's really strong in this area is testing. We've already kind of touched on it. There's JUnit migrations, JUnit 4 to 5 migrations from JUnit asserts to AssertJ if you are so inclined. Mockito, I think this is Mockito 1 to 3, or Mockito 1 to 3. So this is a good place to look to see what's possible today. You'll also notice that all of these recipes can be composed, right? So like the JUnit or the Spring 1.5 to 2.0 actually is a bunch of Spring recipes commingled with this JUnit 5 stuff. So there are a lot of possibilities out there. There is a way of declaratively building these, so you don't always have to write code. You could actually, if it's just a bunch of change types or you change the method names, you can actually do this declaratively. I'm not going to get into that today because we would be here much longer. But if there's interest, maybe we have another session and kind of cover some of those things. So I want to point you out there. The other thing I wanted to point you to is we have a quick start that has basically for both Maven and Gradle. So this would be basically you add a plugin to, we'll just look at Maven real quick. You'll add the rewrite plugin. You'll be able to use rewrite, I forget the command for discovery, but you can list out all of the recipes that are available here. They'll also be available in that plugin. This actually will also kind of go into details about how you might write your own recipe and then expose it into this plugin as well. There's a lot of good material out here. So there's both, Maven and Gradle directions out here. And so I encourage people to kind of come out, and if you're really interested in this stuff, there's a bunch of tutorials as well. So now you're starting to get into some of the details I'm kind of glossing over here because I just want to make this an overview tonight. And then I guess over time, if there's interest, come hunt us down. So with that, I really appreciate everybody coming out tonight. Some things that everybody can do to help us is this, as silly as this sounds, please star the repo. It doesn't matter much for, I guess, for devs. Who cares, right? But honestly, some of our investors look at this stuff. So it's, I think I'm supposed to say investors turn your earmuffs. I think that's what I'm supposed to say, but I don't know. I didn't. Anyway, it helps us. That's a simple thing to do. The second thing is open up an issue on GitHub. If there's some migration issue that is in the forefront of your mind that is either not covered already or something that you would like to see, please just create an issue for us. Modera Inc. is the company that's kind of backing this. So so far the committers on rewrite are all part of Modera, but we would love to get some more community support in here. We always are welcoming new folks to our community. If you go to the OpenRewrite GitHub page, you'll find a link to our Slack. Please join that. We are always kind of, lurking around on Slack and available to ask, questions. We are pretty prompt about answering any questions. And then finally, if you're really interested in stuff and you want to do this at scale, you've seen kind of hints of what, where the SaaS is going, and that's going to be kind of the commercial offering. You can go to Modera.io and fill out a page, and you'll get an invite. So, and with that, I will open it up for questions. I really appreciate everybody for coming.
Yeah, this was really great. Like you said, it looks like magic.
Mm-hmm. Yeah. Not so much magic, just a lot of hard work. I don't know if anybody from Modera teams out there wants to add anything, but I guess that's it. I'm looking
Quick
forward.
Question.
Sure.
Hey Tyler, this is Tassif.
Tassif, how are you?
Good. This is pretty awesome. I was wondering, are there any plans to do more than rewrite with the AST representation of the code, like linting code, etc.?
Say that again.
Are there any plans to do more than rewriting with the AST representation of the code? Like, for example, linting of the code?
That's a good question, actually. That's something that the answer is yes. There are some really interesting things you can do with. So I mentioned, I kind of touched on this a little bit. Because we're kind of using the AST, we can generate the ASTs at build time. We have the ability to kind of add some provenance information into the AST, kind of like origin, right? So that's cool. Now you think about this, if we're able to do that and we're at build time, we could also put something like similar to an agent, to where we can kind of report back where a chunk of code is running. So what's great about this is this goes a step further than your traditional tools that kind of track, like, this jar is running here. This can go inside that jar and actually track down chunks of code. So you can think of how useful that might be, like the SolarWinds attack, which was a supply chain attack where they literally injected code that got compiled into things. How hard would that be to track down within an organization? Well, the answer is we do have, there's some capabilities here that we could go far beyond what we're doing today to kind of do like a bill of materials down to even lines of code. It's pretty compelling. So that was a good question.
Cool. Thank you.
Yep.
Hey, Tyler, this is Sean. Yeah, great presentation. I just wanted to say I agree with one of your statements when you said that OpenRewrite is a game changer for Java development, and I agree with that wholeheartedly. I've gone through a lot of pain, like migrating internal libraries at my company. It's been painful, just like migrating Mockito from 1.x to 3.x, and just seeing all the pre-built recipes that are already provided is just outstanding. I mean, that's like immediate value for pretty much any Java team, big or small.
Yeah, that's a really good point. That, again, I spent, before I worked at Modera, I spent good portions of my life with these migrations, Java 8 to a Java 11. Boy, they're thankless too, right? They're like, you'll spend weeks doing it, and like, as long as nothing breaks, that's great. But if it breaks, then it's, of course, there's a big magnifying glass on over everything. So, but trying to do that across your org is really, really challenging. So.
Yeah, on a recent adventure, I wrote like a shell script that was like literally using regular expressions. Like you said, like regular expressions only get you so far, and they are not ever going to do all the transformations. I mean, and they're faulty. So having like a more sophisticated tool just elevates your capability, and you can guarantee that the result will be compilable Java code. So it's a much better approach.
Yep, exactly. Again, you do all kinds of tricks, right? Like when I was doing an AssertJ unit asserts to the AssertJ, I actually implemented the JUnit assertion class using AssertJ, and then used IDE refactoring to pull that stuff up everywhere. You do whatever you can to kind of fix this. It was kind of like a poor man's rewrite back before I knew a tool like this even existed. Yeah, it can be very challenging, for sure. And I just want to, like the IDEs have come a long way, and you can do some really sophisticated things here. But and that's great when you have your eyes on code and you're in your IDE and you can see it. But what about all those repos that maybe nobody's touched for a year, or just sit out there running? That's kind of where this thing kind of like can also kind of shine. Is you can do safe operations across your entire org. Like the principle, the underlying principle is do no harm, right? So like if we can't do it safely, then the recipe shouldn't do anything at all. So that's kind of a motto that we're kind of standing by. And again, it only helps to get the word out there and kind of build up this community. I could definitely see the recipes growing pretty dramatically once this gets out there a little bit more.
Where will the recording be available at?
I think it'll probably be posted to. We have Modern has a YouTube page, or I can give it to Sean or Spencer and have them. I don't know. Do you guys have a place where you publish these?
We can post it as a comment on the Meetup, and I will also tweet from the Java user group account as well.
Right. Perfect. Okay. So yes, the answer is it will definitely be available. Stay tuned for more details. Okay.
Thank you.
All right. I guess I'll give everybody about 40 minutes left. So look forward to maybe doing this meetup in person soon. I think a lot of people are getting vaccinated, so it'll be nice to kind of do some in-person networking again.
Are you Portland based?
What's that?
Are you Portland based?
I am actually. I just moved to Portland May of last year, so I've been here just about a year now.
Okay, cool.
So I moved right during the pandemic. Thanks.
Thank you.
All right. Thank you so much. I appreciate everybody for coming.
Thanks, Tyler.
All right, thanks.
Bye.
Bye.